Welcome to Acaducation. Hello everyone. I hope you are doing good. So let's start with our next topic, which is pipes and cistern. Although we are taking this topic in a separate module, but we'll deal with the problems based on this topic in the same way as we did with time and work. So I would recommend you to first go through time and work if you haven't, so as to get a better understanding of this topic. So let us see our first question of this topic. Read the question and then we'll start our discussion. Two pipes A and B can fill a tank in 20 minutes and 30 minutes respectively. If both are opened together, time taken to fill the tank would be. So this is our question. So in our time and work lecture, what used to be was two people A and B can do a piece of work in 20 days and 30 days. If both start working together, then time taken to complete the work. So this question is a similar type of question when we compare it to our time and work. There we used to get our work first, right? We used to assume some work. Let us assume our work here, that is the capacity of the tank. Let it be 60 liters. Why? Because it is the LCM of 20 minutes and 30 minutes. So now we have a tank whose capacity is 60 liters. We have two pipes, one this one and other. Now this fills the 60 liters in 20 minutes and this one fills in 30 minutes. So if this pipe, which is pipe A, it can fill it 20 minutes, so I can say that this pipe fills 3 liters per minute, right? We can say this. Similarly, we can say that our pipe B, it fills 2 liters per minute, because if it fills 60 liters in 30 minutes, so this means per minute it will be filling 2 liters of water. So A fills 60 by 20, that is 3 liters of water per minute. Similarly, B fills 60 by 30, that is 2 liters of water per minute. Now if we add these two efficiencies, 3 liters plus 2 liters, we would get in 1 minute they would be able to finish, or they would be able to fill up 5 liters of water. Now they are filling 5 liters of water in 1 minute. So what our work is 60 liters of water. So 60 liters of water could be filled in how many minutes? 60 divided by 5, which is 12 minutes. So this is the amount of time that these two pipes would take to fill the tank. To fill 60 liters of water at the rate of 5 liters per minute, time required is 60 by 5. Let us see another type of question that is asked from this topic. So a tap can fill a cistern in 12 hours, while another tap can empty the cistern in 20 hours. Now if both the taps are opened simultaneously, how long would it take to fill the empty cistern completely? Now what does the question say? We have a cistern, we have an inlet tap which can fill it in 12 hours, we have an outlet tap. In the previous question we had two taps, but both of them were inlet taps. Now we have two taps, one is inlet and other one is outlet. Now the outlet one empties it in 20 hours. So what do we do at our first go? We first of all take the capacity of the tank. And how do we take the capacity? LCM of the number of hours in which the tank gets filled. So let us take the capacity as 60 liters. Now we have 60 liters of capacity and it is getting filled in 12 hours. So can I say that this tap fills 5 liters per hour? This much amount of water is being poured in this tap or in this cistern by this tap, which is pipe A, let's say, or tap A. Similarly for tap B, what can I say? How much amount of water is being ejected out of the cistern? 3 liters per hour, because it is emptying 60 liters in 20 hours. So now I have the individual rates of pipe or individual rate of tap A and B. So we have our inlet taps rate 5 liters per hour. We have the outlet tap rate, that is 3 liters per hour. Now if they work for 1 hour, both of these taps, what will happen? 5 liters will go in and 3 liters will go out. So effectively, how much amount of water will get filled per hour? That is 2 liters per hour. 5 minus 3, right? So if 2 liters of water is getting filled per hour and we have to fill 60 liters of water. So how much time would be required? 60 divided by 2. So to fill 60 liters of water at the rate of 2 liter per hour, we would require 30 hours, because in 1 hour 2 liters is being filled. So 60 liters would get filled in 30 hours. Let's have a look at a similar type of question but with a little variation. What this question says is, a cistern is normally filled in 8 hours but takes another 2 hours longer to fill because of leak in its bottom. What is happening here is, we have a tap, it is filling it in 8 hours, but there is a leak because of which it takes 2 more hours. So if the leak is present, it is taking 10 hours to get filled. Obviously, if there is a leak, it would take some more time. Now it says if the cistern is full, the leak will empty it in how many hours? So we need to find basically this rate at which the outlet pipe empties the cistern. So first of all, what do? We take the capacity of the cistern, LCM of 8 and LCM of 10. So let us consider our capacity be 80 liters. If the capacity is 80 liters, then what is the rate at which this inlet pipe fills this cistern? It would be 10 liters per hour, right? 80 liters is being filled in 8 hours. So 10 liters per hour. Similarly, when inlet pipe and leak is present, so when the leak is present, what is the rate at which water enters this effective rate? That is 8 liters per hour, because 80 liters is being filled in 10 hours. Now we have to take out the rate at which water is leaking out of the cistern. So if I take the inlet pipe rate as I, so I is equals to 10 liters per hour, and I minus leak. I is the rate at which it is getting inside, or rate at which the cistern is getting filled. L is, let's say, the rate at which the cistern is leaking. So I minus L is 8 liters per hour, right? We found the value of rate at which it is getting emptied when leak is present as 8 liters per hour. So solving these two equations, when I put the value of I as 10, we get L as 2. So basically it is leaking at the rate of 2 liters per hour. Now we have to empty 40 liters of tank at the rate of 2 liters per hour. So how much time would be required? 40 hours, 80 divided by 2, right? Let us have a look at another type of question. This question is relatively easy, but what happens is sometimes we get stuck in how to solve or how to approach these type of questions. First, read the question, try solving it for 2 minutes, and then we'll discuss how to solve it. So what this question says, two pipes A and B can fill a water tank in 60 and 30 minutes respectively, and a third pipe C can empty the tank at the rate of 3 liters per minute. If ABC are opened together to fill the empty tank, it gets filled in 30 minutes. Find the capacity of the tank. So earlier what used to happen was, we were given that A can fill it in this time, B can fill it in this time, and C can empty or fill the tank in this number of time or this amount of time. But instead of time, we are given here the rate of C. So because the rate is given, we cannot assume our capacity now in number form. Otherwise it would create a problem at the end. So what is happening here is, we have a cistern, there is an inlet pipe A, there is another inlet pipe B, and there is an outlet pipe C. Rate of C is given as 3 liters per minute. And this we are given that A can fill it in 60 minutes, B can fill the cistern in 30 minutes or fill the tank in 30 minutes. Now in this type of question, what we'll do is we'll assume that let our capacity of tank be X. Finally, we'll be taking up some variables. So let it be X liters. X liters of water can be filled in 60 minutes by pipe A. So when it is working for 30 minutes, can I say that it will be able to fill half the capacity? Because it takes 60 minutes to fill complete, so it will fill X by 2, right? Similarly, pipe B would be filling X liters of water, because in 30 minutes it can completely fill the tank. So this much amount is getting filled by A and B. And in 30 minutes, 90 liters of water is being ejected out by pipe C. So C is taking out 90 liters of water in 30 minutes. Now what this says is, we have to fill the empty tank in 30 minutes. So what is happening? Let our capacity be X liters. So amount filled by pipe A in 30 minutes, we took it as X by 2. Similarly, by pipe B, we took it as X, and pipe C, we took it as 90 liters. That 90 liters would get ejected out, and the capacity was X. So if we form the equation for this question, X by 2 is the amount of water that A has filled, X is the amount of water that B has filled. So this is the total amount of water that has been filled in 30 minutes, and this 90 is the total amount of water that has been ejected out. And this whole part, this should be equal to what? The capacity of the tank. So X by 2 plus X minus 90 is equals to X. X and X gets cancelled out. We get X is equals to 180 liters. So this is the capacity of the tank.